The first lines acquired in a 3D survey give the field crew a sense of the local environment. Because these lines are usually shot over a geologically significant part of the prospect, they are especially important as test lines. If the lines can be rushed from the field to the main processing center, the processors can see the quality of the data, make brute stacks of the lines, and compare them to other lines shot in the area. Our first processing steps use algorithms that are 2D in nature. Bidding and true 3D processing can only be performed after all positioning information is received and processed. This initial processing generally includes demultiplexing the raw data, trace editing, filtering, deconvolution, gain recovery, and noise attenuation.
Remember, this can be done during the first few days of the survey while the crew is in the field. We can even produce a brute stack and compare it to existing data. Generally, the brute stack will be comparable to existing data since we haven't yet applied the full advantages of 3D processing. But if the new data are of poor or reduced quality, we can investigate the field parameters, survey design, and processing scheme, and take remedial action while the crew is still in the field.
In addition to pre-processing these test lines, we can also use these early data to identify line positioning errors. Although 3D surveys are dominated by inlines, if we have a few processed cross lines, we can tie these lines and look for time shifts on reflections at the tie points. These time shifts are especially obvious on steeply dipping horizons. They almost always indicate errors in line locations. In marine surveys, the field crew can also detect line positioning errors early on by plotting what is sometimes referred to as a waterfall display. This is a map of the recorded streamer positions with a vertical exaggeration of the feathering angle. Assuming that the tide and currents are similar during acquisition, the streamer will appear subparallel from line to line. Problem lines are obvious. Now we must find the source of the error. These deviations could be caused by errors in the streamer compass headings, errors in reducing the compass data, or hooks in the cable caused by turning the vessel.